Alright, last thing in 1.5 I want to talk about, and sorry this is stretched to 3 videos, but I think there's some good examples here, and very important ideas with average rate of change, which is really just a nice way to think about slope, that change in y over change in x. And so average rate of change is just the change in y over the change in x for some 2 points, for some points out there in this graph. So you have a graph that is doing something, and if you want to find the average rate between 2 points on that graph, then you just find the slope in between those 2 points. What that would look like in a function problem and on your homework is something like this. If I were to go through and do, let's pick an easy one here first. Number 63 in your homework. It's not one of your homework problems, but 63 looks like this. F of x is equal to a negative 2x plus 15. And they want to know what is the average rate of change between x values 0 and 3. Well, that would, first I need not just the x values, but I need y values for this as well. And so I need to plug these in. So what is f of 0? And f of 0 is equal to negative 2 times 0 plus 15, which would just mean f of 0 is 15. And so this first one is 15. And then f of 3 would be a negative 2 times 3 plus 15, which would be negative 6 plus 15, which would be equal to 9. So I now have my x and y values. And now that I have that, just y minus y over x minus x. And that gives me 6 over a negative 3, which would be negative 2. Which you might say, hey, that's really dumb because the slope originally was negative 2. Of course it's going to be negative 2. Well, yeah, it's a linear equation. The average rate of change is going to be equal to the total rate of change, the slope of the entire function. Now let's look at one that would be far more interesting, say one like 66, where we have x squared minus 2x plus 8. Well, this is now quadratic. This is not a straight line function where we know what the slope is everywhere already. And depending on what 2 points I choose, my average rate of change is going to be different. So for this one on 66, x1 is 1, x2 is 5. And so now I just want to know y1 and y2 for these points. And so to do that, I'm going to find f of 1. And 1 squared minus 2 times 1 plus 8 would give me 1 minus 2 plus 8, which would be 7. And so f of 1 is equal to 7, which means this y1 is 7. And then for the next one, just doing f of 5 would give me 5 squared minus 2 times 5 plus 8, which is 25 minus 10 plus 8, which would leave me with 15 and 8 is 23. Yeah. And so f of 5 is equal to 23, and so y2 is 23. So now once again, y minus y over x minus x, and I have 14, oh I didn't do that right, let's try that again, 16 over 4, which would leave me with 4. So my average rate of change, my change in y over change in x, between those 2 points of this parabola is really 4, because I have like some point here and some point here, and I have that line going through those two. And that line has a slope of 4. And that's what we're talking about when we're talking about average rate of change. Really cool idea, one that gets a whole lot more emphasis when you get to calculus, but if you can understand and grasp that idea of average rate of change right now, of the average rates of change of all the points in between x equals 1 and x equals 5, has this slope of 4. That's a really cool idea that will put you ahead of the pack. Next thing we're going to do is talk about these heights of rectangles. I'm actually going to do one from your homework, so if you go online and watch this, there you go, you get a freebie. 77 is a really cool problem where you have like the top half of this parabola that is cut off. And the whole thing is shaded up here. I'm going to see if I can shade this. Entire thing is shaded, right? And they want to know, what would this, if I drew a rectangle right there, I'm going to change colors, something stick out a little bit. If I drew a rectangle right there out of the middle of it, what would the height of that rectangle be in terms of x? So in terms of x. So they tell me that the function is negative x squared plus 4x minus 1. And then I know these things as well. At this point here is 3, 2, and this one here is 1, 2. Right? So, find the height of the rectangle as a function of x. Well, the height just of my entire equation here is f of x, right? So f of x is just the y point. How tall is my function at any given point? So x squared plus 4x minus 1. So that's the whole thing. That would be like the distance from the x-axis all the way up to the top of my parabola there. That would be f of x, right? So that entire thing is f of x. So really what I want to do is I want to do f of x minus whatever this space right in here is, which is 2. And that will give me h, the value of just my rectangle that is inside that shaded yellow area up there. So if I'm going to go ahead and work that out, that would be negative x squared plus 4x minus 1 is f of x. And then all of that minus 2, because I'm going to subtract away that 2 down there that is not part of the total thing. And so h is equal to a negative x squared plus 4x minus 3. And that's the height of my rectangle. It's so cool to think about understanding that idea of being able to composite these functions together right now, because you're going to use that in calculus to be able to find the area of the entire function. And they're just so much fun. I'm going to go ahead and do 78 as well, because 78 is really cool, because you have this function that is like this right here, and the shaded part is right in here, all of this good stuff. And this goes 1, 2, 3, and 1, 2, 3. And this point here is obviously then 1, 3. And they tell me that my function there is 4x minus x squared. So if I want to know the area inside of here, right, these little rectangles inside, if I have a rectangle like that that is somehow going to add up a whole bunch of these rectangles to get a height, then the height of that rectangle would be the top minus the bottom. Kind of, it's always the same thing, top minus bottom. On the previous one, right, on the previous problem, the top was my function, right? This was the top, and this was the bottom, right? On this problem, the top of my function is actually a flat line. So the top of my function is 3, and the bottom of my function is f of x. And so now, to find the height of this entire thing, I'm going to do 3 minus 4x minus x squared, which would then flip some signs and give me h is equal to 3 minus 4x plus x squared. And to rewrite that as we're used to seeing it, that would be x squared minus 4x plus 3. And there is the height of my really cool, interesting function as such. Now, I think that's plenty for you to be able to be very successful in your homework and to be able to understand some of these basic ideas, well, not basic, but some of these complex ideas we tackle in calculus that will help you so much here in pre-cal.